Welcome to the deep dive. You know, when you watch the final moments of a manual landing, it's genuinely impressive, isn't it?
Oh, absolutely. It's one of the most demanding phases of flight.
The pilots managing pitch, roll, yaw, keeping an eye on airspeed, juggling power, lining up perfectly, kicking off drift, all at the same time. It's pure skill.
It really is. If you break it down just before touchdown, the pilot has to get aligned with that center line, nail a specific sync rate. We're talking maybe 2 feet per second.
Tracing the pavement.
Exactly. And bleed off speed, right? From maybe 1.3 times stall speed down to about 1.15. Then there's leveling the wings and that crucial decrab using the rudder to point the nose straight down the runway, not where the wind was pushing you.
That complexity, that high workload.
Yeah.
That's precisely why today we're diving deep into automatic landing systems, Autoland.
Right.
And for anyone out there hitting the books for their ATPL theory exams, this stuff is absolutely vital. It's detailed, it's technical.
It really is. These are some of the most sophisticated pieces of automation in the sky.
So our mission today is to really unpack it all. We want to get into the nitty-gritty, the systems, the exact sequence, the procedures, the minimums, those ICAO categories.
And crucially, those specific figures and definitions. We know you need those for the exam, so we'll be highlighting them, maybe even repeating them a bit to make sure they stick.
Yeah, this isn't just about knowing that it works, but how it works, down to the numbers. Precision is key, especially when we talk altitudes and signal deviations.
Couldn't agree more. It's about understanding the layers of safety built in. Okay, ready to just bet?
Let's do it. Let's unpack Autoland.
Okay, so first things first. We have to understand the baseline requirement here. An Autoland system isn't just your standard autopilot following an ILS beam down. It's much more than that.
Right, it has to be demonstrably better than the pilot, in a sense.
Exactly. To get certified for automatic landing, the system has to show guidance and control performance that's provably superior to the required performance envelope of a human pilot in those conditions.
That's a high bar. It's not just mimicking, it's executing with near perfection, consistently. So what are the core objectives? You mentioned 4 key points the system has to guarantee. These sound like exam territory.
They absolutely are. Let's list them clearly. First, the system must not disturb the flight path if there's an active malfunction. No sudden jerks or dives if something fails.
Okay, stability is paramount. What's second?
Second, it must have adequate authority for accurate path control, meaning it needs enough muscle to counteract small gusts, slight deviations, and really stick to the intended flight path.
Makes sense. Control authority. And the third point relates to failures.
Yes. Third, it must warn the crew of a passive failure. Now, a passive failure is tricky. It's when a component just stops working reliably, stops sending good data, but doesn't actively send a wrong signal. The system has to detect that loss of function and tell the pilots.
So it needs self-monitoring to catch silent failures. And the final objective.
And fourth, arguably the most critical, the design must allow the intended maneuver to be completed after a failure, active or passive, or alternatively, allow a safe transition to a go-around. The failure shouldn't trap you.
Got it. So don't disturb the path, have enough authority, warn of passive failures, and allow completion or escape. That's the engineering mandate. If it can't do those, no certification.
Precisely.
Okay, let's move to the hardware. What's the bare minimum kit you need on board and on the ground for this to even be possible?
It boils down to a critical triplet. On board, you need a minimum of 2 independent autopilots. These have to be capable of flying the aircraft right through the landing based on ILS signals.
2 autopilots. Why 2? Redundancy.
Exactly, redundancy and comparison. Second, you need 2 independent radio altimeters, RAs. RAs are absolutely essential because they measure your actual height above the ground directly below the aircraft, which is critical for the flare. You can't flare based on barometric altitude.
Right, you need that precise ground proximity info. And the third piece.
The third piece is on the ground. The airport needs a certified Category 3 ILS ground installation. You can't perform an auto land.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best